Hello, this is Jack Jackson. We're going to be looking at solving triangles today, and we're going to be looking specifically at the Sas condition. So in the Sas condition, we're given the lengths of two sides and the length of the angle included between those two sides, and from those three pieces of information, we're going to determine what the length of the other side, the other two angles, and the area measurements are. So we're going to get the measurements of all the parts of the triangle. Now, as we discussed earlier, we looked at this same tab earlier in the course, and we looked at this situation, and we discovered that with the side angle side situation, given any two side measurements and any angle measurement for this side angle side condition, there will exist exactly one triangle size with those measurements. And there's no way to get an exceptional case where it doesn't work. So suppose we just take this and we can click on these measurements here, double click, and then type in a number. Suppose that's 4 centimeters. And let me try again. 4 centimeters. And say the angle in between is 49 degrees. And the other side is, say, 7 centimeters. Well, we could draw this out, and earlier in the course, that's exactly what we did. We used our compass, our ruler, our protractor, pencil, paper, and we constructed this triangle and just measured the other sides. But there ought to be a way to figure this out exactly what they are, and of course that's what this video is going to talk about. So let's review that last time we derived the law of cosines in the tab Law of Cosines, and recently we went over a video of how this is derived. And then when you click on this, well, there's the proof, but this part right here, you click on Show Using the Law of Cosines, and you can see that once you find the basic equation, c squared equals a squared plus b squared minus 2ab cosine of c, that we can easily solve for side c by taking the square root. So notice that c equals the square root of a squared plus b squared minus 2ab times the cosine of the angle opposite that c. And similarly, we can solve for the other sides. So anytime we know two sides and the angle in between, we can use this law of cosines in this form to solve for the other side. And that's exactly the situation that we're in here. If you click on this Show Trigonometric Computations button, it goes through and shows you step by step all of the trigonometry steps to solve the rest of the missing information in this triangle. Over here, this will actually just show you them and even show you the area. And then over here on the right, we have the actual calculations. So notice we're given A, or side 1 is 4 centimeters, the angle between, which is C, is 49 degrees, and angle B, or side B, side 2, is 7 centimeters. That's the side angle side condition. So use the formula C equals the square root of a squared plus b squared minus 2ab cosine of c, and simply plug in what we have for A, B, there's A again, there's B again, and there's angle C, and we should be able to compute this to be 5.32. Let's check this out with a calculator. Now, just to make things a little bit easier to type in, I'm going to store some things here, at least the sides. I'm going to use A, B, and C to store the sides. So I'm going to take 4, store it as alpha A, and 7, store as alpha B. Well, in this case, 4 and 7 are probably easier to type than A and B, but if these are longer decimals, this might be useful. So now we can use this to work this out. Now, I want an angles in degrees here, so I'm going to put my calculator in degree mode. As you see, it is there. Normally we don't do that, but if we're going to be working in degrees a lot, we might want to do that. So we'll say that's inverse cosine of parentheses alpha b square plus I'm sorry, I got to do this one up here first. Try again. Square root of alpha a square plus alpha b square. Of course, I could have just typed in 4 square and 7 square there. Minus 2 times A times B times the cosine of, and I don't have this in store, so I'm going to say 49. Normally I put it degrees, but this is in degree mode, so I can leave that off. And close parentheses. Notice I need I need parentheses around the input for the cosine, and then I need a parentheses around the whole thing that I'm taking the square root of. And this will give me C. In fact, let me store it as alpha C. And this one's kind of important because that's such a long number there, 5.3160788853, rounds off to 5.32 centimeters. But notice that I get more digits. If my original information was accurate to this many digits, then this would be accurate to that many digits. Of course, if my original information is only good to say 3 significant digits, then I would round this off to 3 significant digits. But even in that case, I'm going to be using the number with all the digits when I do further calculations. So be sure that I use this in further calculations. Rather than having to type all this in, I just stored it as C, so now I can do alpha C. So even if you didn't do the A and B part this way, I would definitely do C like this. Now, returning again to the law of cosines, when we take this C squared equals A squared plus B squared minus 2AB cosine C, we can solve this for angle C. You can actually see the steps there. And we see that C is the inverse cosine of A squared plus B squared minus C squared over 2AB. And similarly, we can permute the letters there to solve for the other angles. So once we know all three sides, which we do at this point, we can now use those to find the angles. So for example, to find angle A, it's the inverse cosine of B squared plus C squared minus A squared over 2BC. Notice that you have A squared, B squared, and C squared in the numerator. The one that's opposite the angle you're looking for has a minus, the other two are plus. In the bottom, the one that's opposite the angle you're looking for is missing. You just have 2 times the other two sides. Notice I've put these parentheses around the numerator and around the denominator. That's optional when you're writing it because a horizontal fraction line actually is a grouping symbol, and they're implied. But they're not going to be implied when you type it in your calculator because we're not going to use a horizontal fraction line. We're going to be using a slanted fraction line, which is not a grouping symbol. So it's absolutely important, very, very important, to put parentheses around the numerator and the denominator. Now we're just simply plugging in the numbers here. And now even though it says 5.32, we're actually using all the digits in our calculator. Okay, so here we go. I've stored the A, B, and C. And that's all we use here is the little a, b, and c, or the capital A, B, and C over here in the calculator. But this is what we're going to do here. They're the side lengths. So it's the inverse cosine of, open numerator, alpha b squared plus alpha a, c squared, and then minus alpha a squared, close parentheses, divided by parentheses 2 times alpha b times alpha c. Okay, and that closes the denominator and then close the inverse cosine. And since I'm in degree mode, this will produce the angle in degrees. Okay, now again, if we need that angle again, we'll use all those digits to continue on. But notice it does round off to 34.60 degrees if we go to 2 decimal places. Now I have two options, actually more than two. I can use law of sines, law of cosines, or the angle sum theorem to find angle B. In other words, I could use a formula like what I just did for A. I would have B is the inverse cosine of A squared plus C squared minus B squared over 2AC, and I could find angle B that way. Or I could use the law of sines, but I chose the easiest route, which is to use the angle sum theorem. It's just 180 degrees minus that previous answer minus the original 49 degrees, and that's going to give us the angle for angle B. Now once you have everything else, it's pretty easy to use this basic formula for area, 1/2 AB sine of angle C to find the area, and just use that basic formula we've got, so I can do that on my calculator. 1/2, maybe I could do it like this, 1/2, and then say times alpha A times alpha B, and then say times the sine, and 49 degrees, that was not rounded off, so that was given, so we do it like that. So it's 10.56593412, and of course if these are whatever length unit we have for the sides, this will be square of that. So if the original was centimeters, like it says here in centimeters, then this would be square centimeters. And of course all the lengths of the sides are centimeters, the area is square centimeters, and the angles were all in degrees. Of course if these were miles, if this is 4 miles and 7 miles, then this side would be 5.32 miles, and it would be 10.57 square miles. So, but the units need to be consistent. If this is in centimeters and this is in meters, you need to convert them either both to centimeters or both to meters. So that shows you how you can do this, and of course you can use this sketch, all of you have this sketch, and you can use it to check your problems. I wouldn't use it to necessarily work the homework problems, but work them and then use this to check. And you can come back here and just enter in any value you want, say 7, 5, and maybe 22 degrees, like that. So 7 centimeters, 22 degrees, 5 centimeters, and it constructs it exactly right. And actually, if you print this out, it should actually print it out to where those are actually right in centimeters on the page. Again, it adjusted all the numbers over here, so it shows you all the steps to the calculation. And so that gives you the side angle side situation. In the further videos in this section, we'll go over all the other possibilities. So we'll go over side angle side here, side 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 the next video, then angle side angle, angle angle side, and then side side angle, and we'll even show what you can do in the angle angle situation. So we'll have a video on each of those different ones. So that is the side angle side situation.